Yes, sir.
Yes, sir.
Okay. So just wait for another minute. Well, so I hope all of you have installed that circuit maker. So I think some of you might have installed that circuit maker 2000. So in that case, I don't know how many of you have installed circuit maker 2000.
Sir, I have installed the 2000 version.
Okay, please see that there is a provision of what do you call that? Saving. I think in the file saving, there is a provision of storing that either in circuit maker 2000 format or circuit maker 6 format. So in that case, you may submit circuit maker 6 format. You submit, then we'll be able to check it. So please verify. You can simulate it. I mean, you can save it at circuit maker 6 format also. Anyway, so I think earlier we have seen that 7-segment display. I think you have already used. So what are the things you have used? Just let me recapitulate in a minute. You have used 7-segment display. You have used 7-port. Yes.
Sir, like the first assignment, I have submitted it in Circuit Maker 2000 format, sir. Is it needed that I have to submit it again?
Come again. I cannot follow the question fully.
Sir, the first assignment, I have submitted it in Circuit Maker 2000 version. So, do I need to submit it again? Like,
if possible, huh? If possible, that will be nice, really. So.
Excuse me, sir.
Yes.
So I have the 2000 version of Circuit Maker, but I'm not able to save any file in the other, basically the version. I'm just be able to save it as a CKD file.
I think there is some echo coming. I could not follow your. You said you have installed Circuit Maker 2000.
Yes, sir, but I can't save the file in any other version than the 2000 version. So I'm getting only one option.
yes, I am getting any option for saving it in version.
Yes, sir. We are not getting any option.
I think anyway. Then I think you submit in 2000. I will try to install 2000 in some other machine. So
Okay, sir.
that should not be an issue. Anyway, let me quickly check. I think some of just 1 or 2 minutes about that administrative issues. How many of you have registered late? I think 2 roll numbers I have got. Most probably one of you have mailed me, but others I found in ERP. Are you here by any chance today?
Yes, sir. I registered.
Please write in the chat box your name and roll number.
No, sir. The last mail that you sent, I guess today, 2 p.m. 2 a.m. That I got.
Okay, fine then. Okay, then there should not be any issue. So let me proceed. So you are already having the 7447 and the 7-segment display. You know the reason for putting a resistor over here. You are applying +5 volt over here. This is a common anode display. So there will be 7 lines going from 7447 to this display. And in simulator, I think you may not care much about the value of this resistance. Whatever you put, it will work. But typically in the lab, you may put 330 ohms or close to that, so that you can limit the current of the LED properly. And I think you have interfaced a counter with this 7493 or 7490 so far. Now, today, I think we will learn about two more ICs. One is, let me show you in a separate sheet. One is 7483. Let me talk about this IC a little bit. This is a 4-bit adder IC. Okay, so if you look into its manual, you will find that it's a 4-bit adder IC. So if we say 4-bit adder IC, what immediately comes to your mind, that what it could be?
Adding 1 to the output.
Pardon me?
So like when the output is something, it is doing +1 to it, like binary output 1.
4-bit adder means actually it can add two 4-bit numbers. Okay, so it will be able to add two 4-bit numbers. One of them. So just one moment. So those who have logged into that other meet, that Jitsi meet, are you getting my voice? Anyone in the Jitsi meet? Okay, fine. So, when we talk about 4-bit adder, so basically it is capable of adding two 4-bit numbers. Okay, so it is not just on a one 4-bit number, it will add something like add 1 or something. So it will be able to add two 4-bit numbers. So when you add two 4-bit numbers, first of all, when I talk about a 4-bit number, maybe right now I'm talking about unsigned numbers. I believe you know what is a signed number and unsigned number. So right now I'm talking about unsigned 4-bit binary number. So if I talk about 4-bit unsigned binary, what should be its range? What is the value, the minimum and maximum value? So anybody can turn on the microphone and say.
0 to 15.
0 to 15. Okay, so I think I may not have asked also. It is so simple. So it can have any value from 0 to 15. So when I add two such 4-bit numbers, it may so happen that a carry can be generated. So for example, if I just take this simple example, say 1110, and suppose I'm adding 0110 with that. So can you just prompt me, how do I add it? So it will be 0 and 0 is 0, 1 and 1. Prompt me.
0.
1 and 1 is 0 with a carry of 1.
With 1 carry.
Now these 3 ones are there in a row. Then I should write
1.
1 with a carry of 1. Okay. So now 1 and 1, that should be
1 0.
That should be 0, but that would generate a carry, right? So now just check whether the value is correct. So whatever you have got, 4-bit plus a carry. So what are the original numbers? 1110 is how much and 0110 is how much? So you should be prompt in answering. When you get a 4-bit number, I mean, how do you generally convert it into decimal number? What is the mechanism? Like, I'm not getting any reply. So anybody can unmute and say, please.
The first number is 14 and the second number is 6. And we add them again.
Right. First number is 14, second number is 6. And yeah, I think you have done in that way only. There is probably no other way of doing it, but just because others are not answering. So can you just in a minute, you tell me how do you get this number 14 and 6 mentally? What do you do?
Multiply first bit by 2 power 0, second bit by 2 power 1.
So basically, if you think about the weights, as we are saying, to the power 0 to the power 1, 8421 basically. I mean, from this side, if I write 1, 2, 4, and 8, so wherever you find 1, you are just adding this number, as simple as that, nothing. So whether it is correct, the final answer, it is 16 plus 4 in that case, right? So 20 is the correct answer. Now it may so happen that suppose you want to add two 8-bit numbers, then I may have to add, suppose if I have written rather than 4-bit, suppose I have written one 4-bit chunk, say this 101110 or whatever, and below that something I am writing, but that is just a 4-bit number. So if I need to add 8-bit number, then probably I would have written another chunk of 4-bit numbers over here. And why I am putting it in this way, because right now I am thinking in terms of its hardware realization using maybe this so-called 4-bit adder, which is capable of adding two 4-bit numbers. So maybe I can engage this one 7483 to add these 4-bit numbers. But then after getting, for example, if the number is just like as I have written 1110, say 1110, and this number is 0110. So after adding, you get 0100, but now that is leaving a carry. So if I plan to engage another 7483 and have some other two 4-bit numbers over here as the higher nibbles of these 8 bits, then this 7483 should be capable of adding a carry input to that one also. So what I find that this 7483, particularly when I want to increase the word length, that suppose I want to add more than 4-bit size numbers, say 8-bit numbers, then there might be a provision of generating, a carry getting generated by another 7483, which I need to accommodate over here. So if I think about this higher nibble, it is basically adding two 4-bit numbers with one additional carry input. It will provide me with 4-bit sum, and it can also generate another carry. So if I think about from its functional point of view, then the 7483 should be capable of adding two 4-bit numbers. So I would expect the physical conductors or pins or lines, whatever you call them, for applying two 4-bit numbers. So there must be 8 such lines. Other than that, there will be 4-bit sum output, whatever I think right now we have calculated here or here. 4-bit sum output, one carry output, I am showing it over here. I am writing C out. And there might be a provision of having a carry in, just now as we are mentioning, that maybe from some other 7483, which is in its previous place, a lower byte, lower nibble place, that may provide a carry. So I may require a carry input as well. And often you will, yes.
So can you move your page a little to the right side?
Okay.
Yes, sir.
Okay.
Yes.
Thank you.
Yes.
Yeah. Thank you. So here, in this 7483, what are the pins you are expecting? 4-bit for input. Sometimes you call that operand as A, the other operand as B, and just to indicate that some particular line, maybe it is LSB of A, so you represent them, say through A0, either lowercase or uppercase. So you may say that, okay, A is basically equivalent of 4 bits, A3, A2, A1, A0. Maybe in the manual or maybe in the simulator, you may find that, okay, they are using uppercase or capital letter over here, but they are actually indicating a particular bit only. Similarly for B also. So I will be having 4-bit for one operand A, 4 lines for another operand B. I will be having carry in, carry out, and the sum output. So in some manual it is written as sigma, in some manual I think it is written as S. So from the context I think you will be able to understand. So today we will actually use the 7483 and we will see its behavior, that okay, how you can use this 4-bit adder, what is its characteristics, and if need be, how you can use this in a particular circuit. So I would urge you that not immediately, but just maybe after I finish this discussion, you can download the datasheet for 7483, as I have already told you that whenever you are using an IC, it is a good idea to just download. So you just, I mean, sometimes Google that 7483 and datasheet and download that, particularly to look into its behavior. Though the behavior is understandable, but still, I mean, just to get a comprehensive idea about that, you may download that one. And if you look at the, I think some of the students were telling that maybe in some version of the circuit maker, the datasheet is built in. If you click on that and some information, I do not know exactly, I mean, maybe in 2000 version, my version is not there. So in that case, probably you can download at least partial datasheet in that case. So check, you may check that one as well. Okay, so here if I talk about at least my version of this circuit maker, that is 6.2, then if you open that and then drag a 7483, then you can just apply some signal over here. You know how to apply a signal to what could be the easiest way of applying a signal. Suppose I want to test the behavior of 7483. I would like to say that, okay, whether it is really capable of adding two numbers. So maybe whatever these numbers I have written 1110 and 0110, I would like to apply them into these two input ports and see the output, whatever, I mean, whether it is matching, and maybe I would also like to see the carry output. So what could be a probable way of doing that? Can you suggest some simple way of doing this? Once again, anyone can unmute and say.
So like for giving input, we can like ground the pins and leave the other pins as high, so that we can give the desired input as number.
Right. So you can give a fixed pattern like ground and power supply, but then there might be a problem. Suppose once I set this thing up, now I wish that, okay, let me try some other number where this carry is not getting generated. So then I may have to change the connection once again. So that creates a little, I think I may not say that that creates a problem, but as such that becomes a little bit time consuming. So whether I can have some sort of switch or some such arrangement. So have you seen whether in this circuit maker you can have the provision of some switch or something? In other words, I'm just asking you that what are the different devices? Have you just browsed through the full list? The list is huge though, but at least what are the different things you can have? So anyone, if you have seen what are the things?
Digital sequencer.
Logic switch.
Okay, there is something called a logic switch, which you can connect it to 0 and 1 and something like this. But something else is also there. Okay, so just let me show you, or I don't know, some of you, if all of you are running simulator, you can also check in your version of the simulator. So anyone who is running say circuit maker 2000, so can you run that simulator and share the screen so that all of us can see? So who said who is running 2000? Maybe just start the simulator and share the screen. And please unmute yourself and say that, okay, you are doing, otherwise we will wait indefinitely. So apparently nobody has installed Circuit Maker 2000. Everybody is using 6.2. Yes.
Hello, sir. Hello.
Yes.
Audible? Yes, sir. Can I share my screen?
Please speaking. I cannot follow.
Hello, sir.
Phone.
Yes, sir.
Yeah. Okay. Please share.
So is my screen visible?
Not yet.
So now, hello.
No, I am seeing some circle with A. Probably you have not
Yes,
selected
sir, it
this.
is visible. Sir, hello.
Uh, Others can see that. Maybe I
Yes, sir.
made a wrong input.
Yes, actually, we can see. Maybe if you stop your presentation.
No, I am presenting from just one moment. Let me see. Just one moment. Okay. So there, can you find out in the device if you browse it, just
Sir, which device, sir?
I cannot actually read these things.
Sir, is my screen still not visible?
No, screen is visible, but the resolution, at least at my end, it is not very good. So you are having digital, right?
Yes, sir. I have like digital by function, digital by number, sir. What should I do? Like, which should I select?
And switches are there. Yeah, below I guess there are switches.
Yes, sir. Like I can type.
Maybe the name has been changed in this version.
Yes, sir. There, I type this type switch and this list has come.
But there is only one hex keypad. Is there anything else?
Like, so these are the switches like that have come after I searched it.
No, that I think. Okay, then just let me share it. Let me share my 6.2 version on this. So from there you will be able to get it. So if you just can share the screen.
Okay, sir.
I don't know whether any problem is coming in my screen sharing. So just to see whether you can see my screen. Otherwise, I think because I could not see your screen at some point of time, so there might be a little problem. Just to see whether you can see the simulator. Is the simulator visible?
Yes, sir.
Yes. Okay. So there, I have got that inside device. I went to browse. I think this is the 6.2 version. Probably the interface is slightly different in 2000. Okay, so now I am choosing, suppose switches. Under switches there are so many. So I am choosing digital. Now in digital there are 3. Is it visible, my screen? And is it readable?
Yes, sir.
Yes, sir.
Okay, so this is a logic switch, which I think you can use and click it from 0 and 1. Just if you do a mouse click, it will become 0 and 1. Other than that, there are 2 useful stuff. One is called the hex key. So I believe in 2000 also they will be there. So in this hex key, if you press any of the hex digits, say from 0 to F, so there are 4 lines. This one side is LSB, the other side is MSB. So if you press, for example, A,
Sir,
yes.
so like I can't see your screen, the simulator.
There's but others can see. I mean,
Yes, sir. It is
Yes, sir.
Visible.
It's visible.
I don't know. There is some problem happening because so Anyway,
Orphan, have you stopped your sharing?
Yes, sir. I've stopped my sharing.
Maybe if you rejoin now, you will be able to see.
Okay, sir. Okay, sir.
So if I press any of the hex characters between 0 and F, then it will provide you proper binary code for that. If I press F, it will give me 1111. If I press A, it will give me 1010 and any other binary number. So this is a good way of applying the signal into this 7483, or so to say in any other testing of the IC where you may need to generate a 4-bit code. So what you can do while testing this 7483, so Arpan could join.
Yes, sir. Now it's visible.
Okay, so in this hex key, what I was telling, that if you can connect two such hex key to that 7483, then you can just in your as per your own sweet wish, you can change to any binary code, not necessarily between 0 to 9. You can give even A, B, C, D, E, F, any hex code. And just to see the output you can directly connect to 7447 and a display, and probably by now you are familiar with those characters, that C, that inverted C or T. Have you studied? I mean, some of you must have. If I get
Excuse
a
me,
small
sir. Hello,
yes.
sir. Sir, Utkarsh is saying that he is not able to see your screen, sir.
Utkarshin is in the other meet.
Yes, sir. Yes, sir.
Just one moment. So is it visible now?
Sir, he is saying not yet, sir.
Okay, I may not take much time. So just I think then you can run your own simulator also in that case. If someone can run even a 6.2 there and share, that will be nice really. Okay, so what I am saying, just in the device you may find out. So I will actually stop sharing right now. That will be better, I think. So I will just stop sharing. Just other than that, there is another thing also, what is called a hex. I think others can see still, right? So if you press any key on the keyboard, so it will send the corresponding 7-bit code. So I will come to that one, but right now I think let me stop sharing. The other people I think is having some problem in. Okay, so now just see whether you can see my paper where I am supposed to write.
No, sir.
Is it visible now?
Yes.
Okay, so just let me adjust that one a little bit. Okay, so here whatever I was telling, I think some of you might not have seen my screen sharing. So I was telling that inside the digital devices under switches and then digital, so we are having several options. Out of them, I think 3 options are very useful. One is called a logic switch. So it is basically something which looks like this. You can set it to a logic 1 or a logic 0 just by clicking that. And other than that logic switch, there is something called a hex keypad, hex keyboard or KBD or whatever it says, hex keypad. So it looks in the symbolic form something like this, where if you press anything like 0 to F, Suppose if you press A, then there are 4-bit output. So it will give you the corresponding binary code like 1010. So it's called a hex keypad. Other than that, there is another one called an ASCII keyboard or ASCII keypad, whatever. So in that, the basic difference is that rather than 4-bit code, it will provide you with 7-bit of ASCII code. So for example, if you press A on that keyboard, on even in your computer keyboard, it gives something which is equivalent in decimal to 65. If you press B, you will get decimal 66. So whatever is the binary code corresponding to that, if you press capital Z, it will be like 90 and so on. So from keyboard, I think that 7-bit code goes inside your computer and it interprets in that way. So that ASCII keyboard, if you press any character on your computer keyboard, then the corresponding 7-bit code will appear here. But more importantly, I mean, why in some experiment we may use it, there is some signal. You will find actually there are 8 pins coming out. You may say that, okay, you said 7-bit code, then what is about the 8th pin? So if you see the numbers written are 1, 2, 3, 4, 5, 6, 7, and here it is written S. That S is for strobe. That whenever you press a key, at that time, there will be a small pulse being generated over here indicating that you have pressed a new key. So that maybe if you need to update something or do something else, you can do that. And in that hex keypad, that is actually absent. However, if you are in the campus and come to the lab, you could see that in the lab we are having similar hex keyboard. It though looks somewhat different. It actually looks like a telephone keypad, but with 16 keys, where in each key either a number or the character A through F is written. That is basically all hex digits 0 to F. So in these 16 keys, if you press, the corresponding 4-bit code will be available from that particular box. So it is a small handheld box with 16 keys connected. Other than that, that particular box needs power supply, that is ground and plus 5 volt, otherwise it won't work because inside there are several ICs. And it is also having a strobe signal, that whenever you press a new key, but if you press any key, the output will remain. So internally there is actually a register which holds the value. Whenever you press a new key, the output changes and it gives a strobe signal, which indicates you have pressed a new key. So if you connect it to some circuit where you want something to change, then you can actually look for this strobe signal, which is not present in our simulator's hex keypad. But we may sometimes substitute that ASCII keypad instead of hex keypad, though you will use it more like a hex keypad, but we will use the strobe signal, which is otherwise absent. So for testing your 7483, for example, if I take back this one, so your 7483, just for testing that, you require only 2 simple hex keypad and connect that to, if you are already having that 7-segment display and the 7447, you just connect to that and see that, okay, whether it is matching. And for Cout, for testing that, in display, you will find that there is something called an LED or a, I think most probably it is mentioned as LED in that. So you can actually connect that LED lamp over there, that if LED lights up, that means it's a logic high, otherwise it remains a logic low. Okay, so I would urge you that whenever you are testing such a chip, you may draw a small setup, because it is just basically copy pasting. So you may keep this thing ready as a separate template, because everywhere you will require it. For example, in the last experiment for that clock, you repeatedly required that. In subsequent experiment also you will be requiring this. So in this case, what I was suggesting, that you may connect this 4-bit line to the output of your 7483 and that 4-bit adder, and you test its functionality, that whether carry is getting generated, whether carry is not being generated, whether the input carry, if you change the input carry. Achha, there is a common mistake in the lab. I do not know how the simulator actually takes that one. Many a times, if I say that, okay, in the lab you test a 7483, then students are reporting that they are getting 1 more than the expected result. For example, they are adding 5 and 3, so they are getting a result of 9. So could you guess what could be the probable reason? That means whatever is their expected result, they are always getting 1 more than that.
So, like
Carry put
Yes?
the in should be grounded.
That C in, if you keep it open, then as we have mentioned that in case of TTL IC, it takes logic high. So unless you ground it, then it adds that input carried with that number. Okay, so that could be a probable reason. There could be other reason also, but that is the most common reason that you find in the lab. Students are often saying that the result is one more than what is expected. So that one also you can see, I don't know in simulator whether it will work like that or it initializes that input with 0. So anyway, now after checking that, then let us try something interesting today. So let me show you. Suppose I want that I will be having a simple hex keypad. So and I would like to have a 1-digit calculator. Maybe it's a fancy word right now to call it a calculator. But right now what we mean that 1-digit calculator is basically it will be able to add 2 single digits. So 1 digit means it cannot handle more than 1 digit at a time. So I'm just calling it 1-digit calculator. You may certainly argue that it is nowhere near to a calculator. I may not call it a calculator. So I would have to agree in that case. So anyway, if I say a 1-digit adder, that would probably be probably sounds better. So what we want for this 1-digit calculator is that I would be having a hex keypad. I am just in the background of my mind, I am thinking about that small handheld box with 16 keys yeah, that is available in the lab. But here I think certainly we'll get that hex keypad in your simulator. So if I'm having this hex keypad, I'm just writing it like this as if there are 16 keys. Now you will be having the 7483 fine, which will be able to add to 4-bit numbers. I'm drawing it slightly bigger so that I can connect all 4-bit connections well. Now, my intention that while testing, I said you can connect 2 hex keypad and then see that whether it is working fine. But suppose to an user you are trying to give the 1-digit calculator or adder or sum or whatever you call it, then user will certainly not like to use 2 different keypads for 2 different operands. As we used to do in a calculator, we from the same keypad we give all the operators or operands, whatever. So suppose I think right now the operator I need not have to give. I am saying it is only addition. I will give 2 subsequent digits. So I will press 2 keys successively, one after the another, and I would expect the 7483 to generate the result. So for example, if I press successively 2 keys like 2 and 3, I'm expecting a result 5 over here. So can you tell me how do you design it, or whether you think of any problem?
So will we require to
Yes, please.
So will we require 2 hex codes for it?
I could not follow. You require 2 what?
So will we require 2 that digital gates like the keypad?
Certainly you need something, but what are the things you need? Maybe I will finally connect a 7447 and display, so that is part of it. But other than that, do you need something, or at least do you feel that there could be some problem? So I'm just showing it with an arrow with a resistor.
So I am saying that we will require 2 hex keys, right?
No, that is what I said. That earlier I said that okay, I would require 2 hex keypad for giving 2 operands. But right now I am saying that suppose you want to give it to an user, saying that okay, it is a toy calculator, not even a calculator, it's a summer or adder, whatever you call. It can add 2 single-digit numbers. Then certainly the user may not like to give one operand from one keypad and another operand from another keypad. So it may be, or you may say that okay, the specification of the system should be that there should be just a single keypad, and user will put 2 successive operands through the same keypad. So he or she presses the key one after another. Suppose I first press a key 2, then I press a key 3. Sorry, I press 3 followed by 2. Then I am expecting a result to be displayed here as 5. And now suppose again I press suppose the key 4. then maybe last 2 digits if I consider 4 and 2, then I am expecting the output to be 6 over here. Now if I press 7, 4 and 7 is 11. So can I expect some output here if the result is 11? Do you remember for 11 what is the
So
display?
we'll get an output, but it wouldn't be like 11 or something. It would be like C.
Right, it would be the inverted C, something like that. So I would expect something like this, that I will be pressing successive keys. So whatever are the last 2 keys pressed, then the output that will be shown in the display will be just sum of those 2 characters means those 2 numbers.
Sir,
Yes.
can we use 2 registers and use the strobe key of that SK2 as the trigger?
Yeah, I think from some of your friends, I think I am also expecting some answer. So what is the first problem you are thinking when you talk about a 7483 and a single keyboard, a single keypad?
So the input.
Can you elaborate what do you mean by that?
So like firstly, when we're inputting 3, it should be inputted like either in A or B. So like we would need one more switch, like it would switch on. Like when we press that switch, it will first go to A. Then again we press the switch, it will go to B, and it will be back and forth.
Right. So now 7483, it is basically a combinational circuit. You know what is meant by combinational circuit, right? In your theory class, I think it must have been discussed. So for a combinational network, I mean, how do you define a combinational circuit? Anyone can unmute and say?
We don't know. The output depends only on the present values of the input.
Right. So 7483 is basically a combinational circuit. So the output that will depend only on the present input. Now, if I connect the keypad to only one of the inputs, then certainly whatever right now I have pressed or the last digit I have pressed, that is available over here. But it requires the other digit which I have pressed earlier also available over here. Otherwise, it won't be able to give you the correct result. Now the problem is because I am having a single keypad. If I am having 2 keypads simultaneously, I can generate 2 numbers, 3 and 2. But now if I press one after the other, then how do I do that? So I think your friend Amritaksha suggested to put a register. So what is a register? Whether it has been discussed in your theory class or at least you are having some idea from the name itself?
It has not been discussed in the theory class.
Okay, but from the name, what could you get? That it registers something, so it registers a number, right? In this case, maybe we are talking about, say, if I say 4-bit register and 8-bit register, so it would be able to so-called register a 4-bit number or 8-bit number. It can store that one for some time. So it is not a combinational circuit, it's basically a sequential circuit. Whatever I put at the input, it can memorize that one till another clock pulse comes. And if I have changed the input by that time. So just let me define a little bit about the register, what it is. So if I think about, let us say, a 4-bit register, I'm just talking about a 4-bit register. As the name suggests, it would be able to memorize a 4-bit number. So it must be having 4 input lines, 4 output lines. So whatever I will make available at these 4-bit lines, a pattern of zeros and ones, it will be able to memorize it. Now, how do I indicate that I want to latch these numbers right at this moment, that even if after that it is not available, I change that one, you remember what I have put earlier. So I should have some additional signal for that one, right? So if out of your own interest you have studied somewhere, or you can suggest something from your intuition, how do I do that? How do I indicate it that, okay, I want to store this 4-bit number right now, whatever I have presented at the input? Any idea?
We use a clock signal to register the number.
Generally, there is something called a clock signal to a register, or in some cases there might be a latch signal or load signal, whatever way you say. So today, actually, we would introduce a so-called register which is edge triggered, a positive edge triggered. So you will find that here on this side they are showing it something like this. They say that, okay, it's a clock line, So using this clock, I mean, if we put this type of small triangle, it means it is sensitive to the edge signal, and in particular a rising edge of a clock. You know what is a clock? I think we have already discussed in terms of your last design, that you are applying a square signal in your but your 7493, do you remember it is acting on rising clock edge or falling clock edge?
Falling edge.
Right, but this particular IC right now I am talking about is sensitive to rising edge rather than falling edge. I will give you the number in a minute. Now this one, whenever it gets a rising clock edge, it will latch whatever is available at this input. If it is 0 or 1 or whatever I have applied, it will latch and it will keep that value available. Available means I will get them at the output till the next clock edge comes. Now what happens at the next clock edge? If by that time I have changed the input, it will also update itself. Otherwise, if the input remains same, the output will also remain same. But as such, from functional point of view, I may say that okay, it is sampling the inputs at every rising clock edge and latches that one inside it, and that will become available through this one. So often you will find that they are calling the inputs as D and the output as Q. So D is for something called a D flip-flop. I don't know once again whether it has been discussed in your theory class or from your 10+2 you know about something called a D flip-flop. So anyway, right now you may consider it to be something like data in and data out, that D and Q. So it is the functionality of a 4-bit register. So now can you suggest that how do I use a 4-bit register along with 7483 and a single hex keypad, so that you can get the previously pressed key value also, and that will help getting 7483 two operands simultaneously. Any of you can unmute and say?
So should we use just one register?
Okay, but then where do you like to put it?
Maybe at the like the second input.
Okay. Suppose let me put it like this. Let me take a fresh page. So I am having a 7483. I am having a 7483 where I need to supply two operands together. So suppose this is one operand and suppose this is the other operand. So now whatever you are saying, that suppose I put a 4-bit register over here. I put a 4-bit register over here, and this part we may like to connect to that hex keypad or whatever. So if I put a hex keypad, then how do I make the rest of the circuit understand that okay, I have pressed a new key?
We use the strobe key, strobe output.
Right, but that hex keypad, at least I mean whatever is available in the simulator, that doesn't have a strobe key. So what I can use as a substitute that ASCII keypad over here. But then you may say that if I press 0, what will happen? I am expecting from a hex keypad, if I press 0, all the outputs should become 0, 0, 0, 0. If I press F, then the output would become 1, 1, 1, 1. Okay, so at least if I think about the numeric values, say 0 to 9, maybe people don't like to add A with B to hex characters, but at least that should come properly. So if I connect, suppose without understanding what is ASCII code and something like this, suppose if I connect the 4-bit of the ASCII code is a 7-bit code. So if I connect any of the 4 bits, do you think that will work? Or do I need to have some code conversion or something like this for this particular purpose? Maybe if you're physically in the lab, I would have handed it over to the actual box, that hex keypad with a strobe. But right now, I think that's not possible. So whatever is available, that ASCII keypad 7-bit code with a strobe signal, maybe we can use that. But
so start from so like the LSB 4 bits would be useful if we are like if you want 0 to 9, because 0 ASCII value is 48 and 48
okay, so
binary is 1100, like up to 40.
right. So you have just Googled it, or you know it's ASCII code?
So I knew the ASCII code. I googled the binary value of 48.
Okay, good. 48, I think you will be able to find out really, right? So I think whatever is your friend saying, maybe if I elaborate that one a little bit, out of the 7-bit code, just now we have seen that, okay, how do I find out what is the value of the code? Just by putting the weights like 1, 2, 4, 8. So for a 7-bit code, I need to put 16, 32, 64. So they are the binary weights. So if I press A, for example, what is the code for A I just now mentioned? Capital 65. A, 65. So it would be 1 over here. Here there will be 0. This will be 1 over here. Okay. So your friend has rightly pointed out, suppose we want only from the 0 to 9, at least that should work from ASCII keyboard. We may restrain ourselves from putting A to F, that type of character. But now if I press the character 0, its ASCII code is not 0, its ASCII code is 48. So can you just look at these weights and say, how do I make 48 using these binary weights?
32 and 6.
It is 32 plus 16. Okay. So it will be 32 plus 16. And then 1 must be 49. Okay. So do you see some pattern or something is coming to your mind that you can connect this ASCII keypad in some way?
We can use last 4 bit.
Okay, if you use last 4 bit, then let us see, 1 must be 49. So if I press 1, then 32 plus 16 is 48. It would become 49. In that way, if you add that number with 48, that will give you, so 9 will be 48 plus 9. So it would look something like this, 8 plus 1, 9. Okay. So I think you are very correct. If you ignore the first 3 bits or most significant 3 bits, and you just pick up the lower significant 4 bits.
So we can use that 64-bit as the strobe signal.
No, but the problem is, suppose if you use, I would like to, or the user rather, user would just press 2 successive numeric keys, suppose 2 and 3. In that case, they will still remain 0. Okay, so there won't be any strobe signal generated, but there is a strobe signal in the ASCII keypad. So we will be using that, and for that one only we are going to the ASCII keypad rather than hex keypad. Okay, so you do not have to have a separate arrangement for generating strobe signal, it's already there. So we will use these 4 bit lines along with this strobe signal. Now I think maybe it's a little early to ask you, but anyway, so suppose if I connect this strobe signal with the clock here, let me draw the clock on this side. So if I have connected the strobe signal over here, so just mentally you think of the procedure that I am pressing 2 keys one after the other, suppose 2 and 3. So what will be the output of this register, and where should I connect the other bit? Because essentially my intention is that if I press, if I draw it here, is it visible? If I press 2 followed by 3, I am expecting one of them.
I think we will need another register.
Okay, let us logically conclude that one. That why do you need another register, and what is the problem if I directly connect to this one?
Yeah.
Like only 3 will be like stored in the register. Last thing that we like press.
Okay, so let us see what will happen if I just connect. So I am assuming that okay, I am connecting these 4 bits with this 4 bit, and strobe is that. Right now I am not showing that connection. So mentally you may assume that connections are there. So as soon as I press the first key 2, it will generate a strobe, right? So it will provide a strobe to the register. 2 will be stored, so the output of this one will become 2. Now, if I press 3, the strobe will once again come and 3 will be stored over here. So it will forget about that 2. Okay, so it will be, I think whatever your friend is suggesting, there might be some other way of solving that one also, but the easiest way to put another 4-bit register over here, just above this, whose output you are connecting to the input of this 4-bit register. So there are 2 successive 4-bit registers, or you may say registers in cascade, where you are applying this 4-bit from this ASCII keypad and connecting the strobe signal to the strobe of both these 4-bit registers. So then what will happen, whenever you press this character 2, a strobe signal will appear over here. So both the registers will latch simultaneously whatever is available at their respective input. So what is available at its input, that is if you have pressed 2, it will be 2. So after the passing of the clock edge, that is the strobe signal will fade away in a moment, then 2 will be available over here. But what will be the output here for the second register? Any idea?
Some garbage value.
It could be garbage value. We cannot rely or we may not say that okay, it will be 0. Maybe in simulator it will become 0. Simulator assumes ideal environment, but in lab, whenever you switch on the power, there might be some noise. So there could be a garbage value. So now where I am supposed to connect the other side of the these 4 inputs.
The output of the first register.
Output of the first register, because as soon as I press 3, what will happen? Now 3 will come over here, and because the input of this register is 2, it will also get the same strobe signal whenever I press the second key 3. So its input is finding 2 at its input port this line, so it will store 3 inside it. 3 will become available at its output. So after I press 2 successive keys, 1 will be appearing over here, which I have pressed the latest, and before that whatever I have pressed. So am I writing it correctly? 3 will appear here or 3 will appear here?
The 3 will appear above.
3 will appear above, right? So the second operand will appear behind this, because earlier it was 2, so 2 will come over here. So maybe if I use a different color, that after 1 cycle, we have already mentioned whatever we have written in red, that here will be 2, here also it will be 2, here it will be garbage. When I press 3, then 3 is coming here and the strobe signal is generated. So it will store 3, so 3 will be available here as well as here. But here, because earlier value was 2, now it is getting a strobe at that time, 2 will appear over here. So whatever earlier we are calling it garbage, now it will change to 2. So now 3 will be available here, 2 will be available here, which I have already connected to this point. And these 4 lines, I mean the output of this first register, now I can connect it to here. This is pretty straightforward, I think, right?
Sir, can you explain again why there will be 2 in the last register output?
So let me just, because otherwise it will look clumsy. So let me just redraw this portion somewhere else. So I'm just drawing 2 4-bit registers, one after the other. So this is a 4-bit register. This is another 4-bit register.
So,
I'm connecting them in cascades.
Sir, can you just mention what does the stroke signal do?
Yes. So I'm connecting this one to this keypad. It is having a strobe signal. Now she is asking that what is the purpose of the strobe signal, or what does it do? So strobe signal, it is something like this, that whenever, suppose if it is an ASCII keypad or a hex keypad or whatever. So though in simulator you may not see multiple keys, but think about your computer keyboard that is having so many keys. So whenever you are pressing a key, the corresponding code comes over here. It's basically 7-bit code where we have not connected this higher 3 bits. So the corresponding codes will appear here, as well as there will be a short-lived, so how much will be its duration, that depends on the specification of that keyboard. So whenever I press a new key, other than modifying this output, it is also generating a small small means a narrow pulse, which is called a strobe signal. So the purpose of this one, for example, just now as you can see that maybe we would like to register that I have pressed a new key. So to indicate that event, to signal that event, the strobe signal becomes useful. That whenever I observe a pulse at the strobe output, I know that okay, the user has pressed a new key. Okay, so strobe signal means I can use it for different purpose, but as such, if I just look into the strobe signal and if I find a pulse over here, I know that user just now has pressed a key or rather released a key. So whether that answered your question?
Yes, sir.
Okay, so here how do I use the strobe signal? I am connecting this to both the clock signals. I mean clock signal of both the registers. I assume that okay, a rising pulse, a positive going pulse or rising edge will latch that one over here. So now what is happening? I think who was asking that question, I think be a little attentive. So initially I may say that okay, I do not have any idea that what is the output of the ASCII keypad or what are the contents of the register, because I have just now switched on the power. Maybe in simulator it will be all initialized to 0, but in real life you may have got some garbage value. So you may not know that what will be the output of this ASCII keypad. It can be garbage. Then similarly the output of this 4-bit register also we do not know what is its output. And subsequently if this 4-bit register is having 4 output, 4-bit lines, that is also I do not know. So I just put a star for that, garbage or unknown. So now I press a particular key over here. Okay, so whatever is that key I press, suppose I use 2 different numbers now. Suppose I use say 4. So if I have pressed the key 4, then what I am expecting? I am expecting that the output over here will provide you with the binary value of 4, that is 0100. Even if it is ASCII keyboard, just now we have seen that okay, we can get that number. So it will become 0100, essentially 4. So I am just writing its decimal equivalent of 4. And why? I mean, what will happen to the output of this register? You know what a register is doing. It is having a clock signal. Whenever there is a rising edge, it will latch whatever is available over here. So could you guess what will be the output of that?
4.
It will also be 4. But why it will be like this? Because I have got a strobe signal and I assume that the output of the ASCII keypad is settled before the generation of the strobe signal. So that is why I think in most of the keyboards you will find that rather than when you press the key, at that time it is not getting generated. If you release the key, at that time it is being generated. So it assumes that okay, you keep it for sufficient amount of time so that the output is stabilized. Otherwise what will happen, as soon as you press the key and the strobe signal is getting generated, it may so happen that it takes a little while. Even if a few tens or hundreds of nanosecond later than this age, then this register will not be able to capture that. So it is important to generate the strobe signal after the output stabilizes. So that is why generally that is being done, that whenever the strobe signal is being generated, I mean whenever you release the key, at that time it is being generated. Otherwise you could have used a 4-bit register which is sensitive to the falling edge, because then at least this much of the width, I mean whatever is the width of the pulse, that much time you will get, and you may assume that by that time it will stabilize. But if it is not, then you may not get that 4 to be latched over here. But in this case, I think we may assume that. And what will be the output of this 4-bit register?
Garbage value of the previous register.
That will be garbage value. So essentially, the previous input is getting transferred like this. Okay, over here. Now, if I press another key, suppose now I press 5. So if I press 5, then another strobe signal will be generated after it settles to 5. 5 is 0101. So then this 5 will be latched by this because the strobe signal is going over there. And by the time this is getting a strobe, it is still 4. It has not completed that change yet. So it was earlier value was 4 when it gets the strobe signal. So its output will also become 4. So now I will get 2 successive keys, whatever I have pressed, that 4 and 5 as the output of this register. The latest one will appear over here and the earlier one will appear over here, because gradually it is moving just like a ripple from one output, one register's output to the other register's output. So once again, whether that operation is clear or still you are having a doubt, I should explain a little more.
Sir?
Yes.
So what would happen if the lowest 4-bit register doesn't have any stroke signal? Like if we don't attach it.
Because the functionality of the registers, I mean, right now, whatever we are assuming, that whenever it receives a clock input, I think I have drawn it here, that whenever it is receiving a rising clock edge, at that time it is sampling that whatever is at its input, and it is storing that one inside it, making their code available at its 4-bit output. So if I do not connect anything at the clock, so it will not be updating itself. Okay, so our purpose will not be served. So our purpose is that whenever a new key is being pressed, so that the values are getting, it is progressing through this chain of register. If I put another register, for example, if I put 4-bit registers, then I could have latched 3 successive pressing of the key rather than just 2. Now it will be forgotten. If I now press another key, suppose after 5, if I press 6, so now 6 will appear over here, and since it is getting the strobe signal, it will become updated to 6. And when it got the strobe signal at that time, this output was 5, so 5 will appear over here. So at this output, I will get 6. At the other output, I will get 5. But 4, now it will be forgotten. So yes, once again, okay. So any other query, any other clarification, if you feel, because perhaps it has not yet been discussed yet in your theory class. So should I proceed?
Yes.
Okay. So if there is no other query, then right now it is apparent that, okay, whenever I press 2 successive keys, one of them will be available at this output of the 4-bit register, the other output will be available at the other output of this register. So then if I can tap these 4 lines and use the other 4 lines and supply these 2 with to this 7483, that one will come from this register. So we have got 2 successive registers, one after the other. So these 4 lines are coming from here, and these 4 lines. So one of these 4 lines I am taking it over here. The other 4 lines I am taking it from here. I'm just showing it just like a single arrow. So I am putting these 4 bits over here. So any other thing which you think I need to show? I have not shown the strobe signal. So strobe need to be connected here as well as here. Any other thing? Carry in has to be connected to ground, otherwise you will get 1 more than the expected result, this output. Now where will you connect these 4 lines and where will you connect this?
The 4 lines can be connected to the driver, and the carry we might connect it to some LED.
Okay, so in that case, I think you will be able to sorry, you will be able to see that, I believe. So what should I say? Okay. But the problem is, if I share my screen, I'm just trying once again, if I share my screen, whether it will be visible to you or not. So if I show my entire screen, I am sharing. Just see whether the simulator is visible.
Yeah, it is.
So I don't know, some of you might be having problem. So this is what I think just as a test circuit I have made. And then could you see any difference or anything? What are the observations that whatever we have been discussing? What are the additional information you are getting from this diagram, or do you find some anomaly somewhere?
There is a NOT gate.
Is there a buffer or a NOT gate?
That is not a buffer really. It's, so I think maybe I can show you what is that. So is it visible by any chance? The resolution is sufficient so that you can read it?
Yes, sir.
Yeah.
So device is a buffer. So I think some of you are asking whether it's a buffer or a NOT gate. So it's a buffer, it's not a NOT gate. And the number is 4050. It is basically a CMOS buffer. I think in TTL there has been some problem, so I used a CMOS buffer. So you may note down the number. I think that is probably to generate that delay. Just now I was telling you that, okay, if the strobe signal comes a little earlier, then it settles. In practice, I think you will get sufficient propagation delay, but in the simulator, everything is ideal. So the propagation delay is not there, and the age is actually coinciding with the settlement of the input. So the register is actually missing the value if I do not use this buffer over here. So in reality, you may not really have to use this buffer. Okay, but at least in simulation I am doing. So what are the other observations? First of all, I have not mentioned the number of the register. So it says 74. Can you read once again?
73.
74 LS273. So you may consider it to be 74273. Essentially 74273. Now, do you think it is it's a 4-bit register? I have used 2 of them, and exactly the way I was telling you, I have connected this first 4-bit to first IC, so-called U1, Unit 1. I think the name is given by the simulator whenever I place it.
I think it's a
8 bits.
Right, you are very correct. Because just by looking at that, you can find out D0 to D7. And outputs are also Q0 to Q7, so it's basically an 8-bit register. So I could have used a single 74273, that 4-bit for the first as a first 4-bit register, and the second bit second 4 set for second register. But then the connection would look very clumsy, right? The output of that Q0 should be back to D4 and so on. So just to avoid that clumsiness, I have used 2 of them. But it's a 50% utilization, so it is gross underutilization. I could have used just a single one. In practice, in lab, actually, you are supposed to use the single one. So right now, I am not using higher order 4 bits in any of these 273. However, you may say that, okay, if I somehow or for some reason I would like to use the higher order bit of the ASCII keypad, then probably I need not have to change the arrangement. So you can still keep it. But anything more you look at that?
So
there are some.
Yes. So what is the connection with the carryout? Like what's the L1?
Okay, that is that LED. I think if you look into that display, there you will find that there is a possibility of connecting an LED or a logic probe to that. So I have just connected to that. So let me see device data. Okay. So it is basically, I have chosen a logic display. It is not really an LED, because if it is an LED, I should have got 2 connections. So it is something just for observing that what is its logic. So under the display, I mean, it is equivalent to something like an LED. Only thing is that it is not drawing any current. So it is just a functional representation in the simulator, you can see. Or I do not know. In practice, I think in the market there is something called a logic probe, which looks like a ball pen with a tip. If you connect it over there, it will show that, okay, what is the logic, whether it is logic 0, logic 1, or if it is toggling between logic 0 and logic 1, and some output either digital or by the color of some LED it shows. So it is like this. So I have put that logic display. As you can see, that 100 meg is its impedance, so it doesn't draw any current practically. So whenever it is high, it will lit up. Lit up means this portion, wherever I am putting my cursor, it will show some indication. So I'll see whether I can show it to you or not. Another thing probably you'd like to see. Could you look at that where I am pointing the cursor?
Yes, sir.
So is it visible? I mean, what is written over there?
CP. CP and MR.
So CP, there it stands for clock positive. Positive means for positive going edge, I think it would have. And the second one, that is, I think we have not mentioned yet. What could that be? You see, it is written in
reset.
Master reset.
Master reset. Right. It is, so some of you might have already downloaded the datasheet, or maybe from your intuition you can look at that and maybe expand it. The full form could be master reset. And there is a bubble. What that could imply?
Low level triggered. Active low.
So that is the way typically we interpret. Whenever I find a bubble, that means it is active low. So if I make it low, it will be reset. So what could be the purpose of that? That rather than living with the garbage value, whatever just now we are mentioning, I can, if I wish, maybe for this case, I do not need to reset it. So that is why I have connected both of them. They are active low, you see. I have tied them together and connected to plus 5 volt. So in reality, you may say that, okay, if I keep them open in TTL series IC, that also will consider to be open. So is it a good idea to keep the output open, I mean an input line open, or I should explicitly tie it up to high value? Any suggestion? Any
If it is open, like external noise could disturb and cause errors.
Right, you are very correct. If there is some high value of external noise, sometimes you will find that it is getting reset. Okay, if there is a noise which will bring that pin somehow to low value, crossing the logic threshold. So just to be sure, I am connecting it to plus 5 volt, and maybe another reason this simulator is not recognizing that it is logic high when it is open. So in either case, I think I have connected it. That means I am not using really the reset. So I am still living with the garbage in that sense. So if I press anything, it is not yet run. So I reset that. I am running.
So you're not audible.
So your voice is lagging. Yes, your voice is breaking a lot.
So can you hear me?
Yes, sir.
Yes. No.
I think that simulator hanged or something happened. So anyway, is that document visible by any chance? Whatever I am showing on that paper.
No, sir.
No, sir.
No, that I think I have come out because I think it was not responding. So just let me draw it. So just see whatever I'm drawing, is that visible?
Actually, so your page is not visible.
You have not shared, I think, the screen.
Just a moment. Now probably it's visible.
Yes, sir.
Okay. So,
sir.
Yes.
So like if I add two numbers, my maximum output can be 18. So how will the display show that? Like it will show, how will we know what is the output if it goes beyond like 10?
Okay. So right now is the drawing visible?
Yes, sir.
Okay. Just one moment. So here with this 7483, whatever you are connecting basically a 7447, which will go to the display. I'm showing the display on this side. It is going to the display. And the carry out pin, I assume that, okay, carry in pin you are connecting to the ground. So the carry out pin we are connecting to either an LED or in the simulator, as I have shown, something like a what it is called, logic display or something, L1, as I was showing at that time. I think the simulator, I think crashed or something happened anyway. And the circuit maker is actually notorious for crashing, particularly if you try to drag anything beyond that drawing window. Many times I think it creates some such problem. So here, just one moment. Once again, I think, is it hanging? No. And now after so much time, the simulator has woken up. But anyway, I'm not going to share the screen once again. It may repeat the same thing. So I think your question is that maximum value could have been 18 if I press 9 successively, I think. Then is that the question? I got it correctly?
Yes, sir.
Okay. So if I press 9 and 9, then I am expecting a result of 18. So 18 means if I consider the carry also, then the output should look something like this. It should be 16, that is, it should generate a carry, and the rest of the 4 bits should give me. Anything you are saying? Hello?
Excuse me, sir.
Yes.
So the screen is mirrored. I mean, everything is seen in mirrored way.
Right now also it is like this?
Yes, sir. You are presenting the entire
Okay,
screen.
okay. Right now is it okay?
Nothing is visible.
Just one moment. Hope now it is okay.
It's again the same. It's mirrored.
Anyway, I think I'll just take a couple of minutes. So rather than trying to fix that. So whatever I was telling that, okay, if you are having something like a 1 at the position of this carry out, then you will find that this lamp will lit up and the output should be 0010 is 2. So you will get a display of 2 over here. Okay, so that will say that, okay, this is 16 plus 2. So you will get an 18. So in that way, you have to interpret right now. And maybe some later experiment, we will do something called a BCD correction or a binary to BCD converter. When we design that, and then I would ask you to put another display over here. So that will convert to the human readable form of 18. And by any chance, are you aware that from a binary, how to convert it into a BCD form?
Like you mean the addition result?
So you need to add 6.
Yeah.
whenever there is either a carry or it is beyond that 9 value. So in this case, if you add 6, it will become 8. Okay. So the first digit you will display in another 7-segment display, and this 2 plus 6, it will be 8. You will be able to display in another one. So maybe that will be the next experiment. So if some of you wish, you can actually go ahead a little bit with that. So
like then for outputs like 12 and 13, then I think like inverted C, those figures will be displayed only in this case.
Come again, I could not follow.
So like now the output is like 12 or 13, then what would be the display?
Now you are saying, okay, so now if it is within this 4-bit value, there won't be any carry. Okay, so for example, if I press 9 and 1, it will be 10. So then the output code here will be 1010, and if you feed 1010 to 7447, so then I hope you recall, it will look like this. If the result is 11, it will look like this, and so on. If the result is up to 15 anyway, 1111, do you remember what is 15?
It'll be a blank.
15 is blank, no display. So if you see there is no display, and if you are sure that okay, it is not because of any malfunctioning, say you have not connected power supply or something, then you know it is 15. For 14, it would look like a small t, a lowercase t. So it will give you right now something like this, and unless you do that binary to BCD, that type of conversion. Achha, in the other window, is it now okay?
So it's fine, but the quality is very blurry. Even in Meet, it's showing that your connection is poor.
So next day probably I will change that link so that I can have all of you in the same slot, but try to come in time, okay? So
Sir, I joined on 2 p.m. but it was denied since then only.
Oh, I'm not sure why it happened like that, but anyway, so next day maybe from a single one I will try to do that. Okay, so that's all. So basically today's experiment, I think I am giving you everything just to be become a little familiar with that structure and this drawing. So you just check it out that you are able to connect the ASCII keyboard with strobe signal. So you remember the number of these registers. Actually, we are using only half of this 4-bit register. So I may still prefer that because the next experiment may actually require this connection. So with minimal number of changes, you can do that. So this is 74273. Okay, that is the number of the IC that you have used. So basically, that's an 8-bit register. It's not a 4-bit register. It's an 8-bit register. There is another 8-bit register called 74374. Only difference is that it doesn't have any clear. Here you are using that so-called master clear or MR, that master reset. There is nothing like that. Only thing is that there is something called tri-state. There is a provision of tri-stating. You know what is tri-state?
There is an intermediate high impedance state.
No, that might be undefined. Tri-state, it can be something like this also, but mainly if it is remaining floating. That's an open circuit. We often, so sometimes you may find that okay, through a common bus we can connect many of the chips, and then only one will talk at a time. Talk means one will take the control of the bus and will feed something to the bus. The other thing will try to withdraw from the bus. So how can we do it? We can say that okay, we are making the output tri-state. That means we are neither driving it high nor driving it low. We are basically
that would be a high Z value, right? The output is a high Z value,
right? So that 374 is having the provision of tri-stating the output, or I mean, if I use your words, it is making that high impedance output. So the only difference between 273 and 374 is that it is having a provision of reset. It doesn't have, but it is having a provision of tri-state. So in this case, you could have used either one because I do not require the reset. But anyway, maybe for some other experiment, you may require the reset in provision. So you may use 273.
Excuse me, sir.
Excuse me, sir. Yes.
So like I had a doubt, like so we adjusted the situation where 0 to 9 outputs were there, So we took the 4 bits from ASCII digital switch, right? But sir, like now if I want to put 10, I cannot input like A and get 10.
No, here actually that is what I have changed the specification a little bit. I said that, okay, you are giving it to some other user who will be using it for a single digit addition. So if I say digit addition, then a general user will put only numeric value between 0 and 9. Only, okay, so maybe an engineer would put A, B, C, D, F, but right now I think because of that, if it is in the lab with that keypad, you can really try that one. But because this particular hex keypad here doesn't have a strobe signal, and there is another experiment also, but that is a little bit tedious, that if I can have a provision of generating a strobe signal from the hex keypad itself, but then that one will require so many additional ICs and all, but that could be a good exercise also. If you do it out of your own interest, that is also possible.
Sir?
Yes.
So could you please explain that MR part again? Why we are joining the MR of both the registers?
Come again?
So the MR part of both the registers, we are joining it, right? So could you please explain the reason?
No, MR part means it is just for resetting, right? So when we would like to reset that, I think in my this drawing I am not showing that. So in that maybe simulator when I have opened, probably you have seen that. So the master reset, I mean, if I like to show it here, that how will it work? If I make it low, then it will be resetting those registers. Okay. So I may like to put both the registers to reset state simultaneously. Then I will connect them together. So maybe I use a different color to indicate. Whatever I am drawing, is it visible?
Yes.
So if you wish, you can keep them separate also. That okay, I want to reset only one register for some reason, but doesn't the other register should not reset. But for my purpose, I have just connected it because I am not using this reset and kept it connected at plus 5 volt. That is logic high, so that I do not want it to be reset, because if I connect it to the ground, they will not be able to register. It will remain at the reset state. All the outputs will remain 0, 0, 0, 0. So just to avoid that, I have tied them together and making it logic high. That's all.
Okay, sir, got it. Thank you.
Okay, so maybe you can just practice this one a little bit, and this one really doesn't have much design challenge for today's. It is just because you have probably installed the simulator, so you try this one. So in earlier case, as I said, that most probably the 24-hour clock and 12-hour clock, there is a small element of design challenge there, that for 12-hour clock, it has to be reset after 12:59 to 0100 rather than 0000. So that was a small design challenge, and I said that, okay, it's not mandatory. Maybe those who are looking for a relatively higher grade, I think may try that one. In today's case, I think we are giving it a plain simple thing, that is just connect them over here. And once again, I think last time I told you that, okay, do not take the fun away of this learning process. If you run too much about this deadlines and all. But I think some of you have written me in the morning that, okay, everybody is getting panicky or something. Who is that? Pranav. I think, Pranav, are you here?
Hello, yes, I am here.
So I think there is nothing to panic about. I do not know. I mean, though you say that, okay, I'm writing on behalf of the whole group, but
no, sir. Like many of us like messaged me for it.
I got, I think, 3-4 mails only, but in a class of 109, I think. But you should not get panicky or whatever. I mean, I wrote him in a strong language. I said that, okay, hell will not break loose if you do not submit that. So take it in that spirit. What will happen if you do not submit? So do you think you will get F? You will.
No, sir. Like yesterday only I came to know that I have to complete it by today.
No, that is because yesterday only I have circulated that, but probably in the class I have mentioned that I will give the time till the next experiment. So most probably I have announced, maybe you have missed that. But once again, I'm saying that don't take the deadlines and other things too seriously, because I think some students are really facing problems. I know about the connection, power, even the resource. Some of you might not be able to install it properly. Okay. Only thing is that if you misuse that thing, I mean, so that is the only fear from my side. Otherwise, I trust my students. Whenever they say that, okay, there is a problem at my end, I understand that it's a genuine one. But I really feel, I mean, somewhat morosed when I find that, no, the students are actually cheating in the sense that, okay, they are having everything fine. They're just trying to buy time because of, I mean, some other reason they're doing something else. But if that's a genuine reason, certainly I think every time we consider that. Okay, so we may not have to.
Sir?
Hi, yes.
What will be the deadline for today's experiment?
It is supposed to be 5 o'clock today, but you take your time. I'm not closing that one right now, okay? Because anyway, there is I have not yet circulated the link for that. But every such form that is having two fields, you will find date and time. So please fill them properly. That at what time you are submitting. I mean, sometimes I think some people are either faking the time, so that should not happen. So yeah, that's all.
Sir?
Huh.
So like if you are submitting in 2000 version, like can't you open it in your like 6.2 version of Circuit Maker?
Right now I am not being able to.
Sir, I think you can do the vice versa. Like if you have a 6.2 model, you can open it in the 2000 version.
May not be.
So I think 2000 is the updated version. So I think if you have 2000, you can open 6.2 in 2000 version, I think.
Probably so. But I'm trying to just look into the format of this file. Yesterday I received, I think, both the files from one student. And then I'm finding that maybe I can find out that what are the changes, because essentially they are having more or less the same thing. Sometimes maybe the name of the components is slightly different or something. So it is saying that I am not being able to find it in the library or some such thing is happening. So I'll try to find out. So you may not have to take that botheration, I guess.
So sir, we can like submit it in 2000 version, right?
2000 version, but if your that 2000 version supports the savings in 6.2, then I think you may try that one also.
Okay, sir. Sir, actually, sir, I have tried to install the 6.2. It's not installed.
Sir, excuse me.
Yes.
Yeah, can you keep the deadline till tonight, midnight? Because like we have another class from 6.
I'm saying that I'm not putting the deadline at all. I mean, there is a provision of keeping that deadline in the form, that the form will not accept response after this time. So I'm not putting that one. I'm keeping that blank. So you submit whenever you fill, and but
no, but still
date and time properly. That's all.
Yeah, but still, there should be like a formal deadline or something like that, right?
No, that's what I'm saying. That try to right now it is 4 o'clock. Not even 4 o'clock. I think 3:45. So you are still having 1 hour and 15 minutes just for this lab, scheduled for this lab. So I guess if you have practiced it a little bit, maybe you can complete it within 30 minutes or even less. There are hardly, I think, 6-7 components and the connections. But you have to be a little careful about saving your works maybe every 5 minutes or so, because if it crashes, then you will lose your unsaved part of the work. So try to complete. I will maybe if you want to drag it till midnight, I am considering official deadline to be till midnight.
Thank you, sir.
Okay, so any other issue, any other thing you would like to bring it to my notice, because
so today, sir, so we have to do this one-digit calculator simulation, right?
Right now, and maybe I think because it's a small task, maybe I can tell you about the next portion also. That why I said that I'm calling it a one-digit calculator. Next time I will say that rather than pressing 3 and 2 or whatever, I'd like to press the operator as well. So I would like to extend that one-digit calculator's scope not only for addition but at least to subtraction. So addition and subtraction, both it should be able to handle. and I may put some keys, for example, either plus or minus. If it is an ASCII keyboard, I can really press plus and minus. If it is a hex keyboard, maybe I can add, I can put that key A for addition, B for subtraction. So I will put 3A2 to indicate 3 plus 2. I will put 3B2, meaning that 3 minus 2. Or if it's case of ASCII keyboard, I can say that, okay, 3 plus 2 or 3 minus 2, that is also possible. So when I do that, I am expecting a result of 5, I am expecting a result of 1. You may say, what will happen if I do 2 minus 3? So that right now, I think we are not defining for the time being. So that will be the next part of the experiment that extend this, but I will give you proper hint and other information, because I do not know, the theory class might not have progressed that much, but probably from your, I mean, those who have taken computer science in your 10 plus 2, you know how to subtract two binary numbers, right?
One's complement, sir.
Two's complement, basically. So, so how to do that in hardware, you need to think of a little bit. So because of just by looking at this key, A or B, whatever I am pressing, or plus and minus, you need to identify which operation I am looking for, whether it is addition and subtraction, and accordingly you see that, okay, the data should flow inside the hardware. Okay, so that is the small thing, but as I said, that I will also give you some hint about that. At that time, you will require 3 such 4-bit register, because you need to store the operator at that time also. If you press 3 keys successively, then you will be requiring 3 4-bit registers. Okay, so this much I am just telling for those who complete it in very quickly and go for next experiment. And you may download in between the data sheet for 74883, that is 4-bit adder, and 74273, and if you wish 374 also, that 8-bit flip 8-bit register with master reset, or 8-bit register with tri-state facility.
Sir,
okay.
I have submitted the last assignment twice. I mean, yesterday I completed the 12-hour clock, and I thought I won't be able to complete the 12-hour. So
fine.
Now, oh, it's fine. Okay, thank you, sir.
Do you have some other question related to evaluation or something?
No, sir.
Okay.
So like this next part of the experiment that you have told, this like the operator is included, that you have to do next week or this week?
Next week means it will be discussed on next class 26. So I am not expecting you to submit anything about this subtractor part before 26th. So I will discuss only after that. I would expect you to complete the design and give me the output.
Okay, sir. Okay, sir.
Okay.
So tonight we have to submit only the adder part, or
only the adder part? So it is basically practice. I mean, you can think of it's a giveaway marks kind of thing. That just to get yourself familiarized with the simulator, that how to use it and so on, so that next experiments you can do smoothly. So this week, after this week, I think there should not be any complaint about the simulator, etc. And whatever, I mean, that should be from either side. I should not also complain that why you have submitted in 2000, I am not being able to read it. So by this week, I have to also make some arrangements so that I can open both the file 6.2 as well as 2000. So I mean, from your side, you see that, okay, you run either on of this simulator, either 6.2 or 2000, and the simulators are actually very helpful. I mean, just whatever I am saying, beyond that scope also there are, I mean, so many other components and so on. Just browse sometimes that, okay, what are the various components there, because in that scope of say 8 to 10 experiments, you may not be able to explore not all, even say 10% of the full full library of that. Okay, but probably what we will try to do is to give you a little foundation where from you know that, okay, how to read the manuals, how to read the functionality of a new IC, how to think about building a new subsystem or system, and so on. So that much thing I think we will try to train you. So any other question? Yes.
So I'm in Gypsy Me.
Yes.
And here there was many communication gap. And
I know, that is what I said, that from next week I will either shift to MS Teams. I do not know,
yes,
Teams.
Sir.
all of you are having good experience with MS Teams?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Better than Meet.
Either I will go for MS Teams or I will go for the professional Google Meet where I can handle 250 students together. Okay, but I do not know. You are all mature.
I think institute has bought the license.
I just asked for that. They have not replied yet. So I just asked CIC to give me that. So I don't know. There are some problems at their side also because of the heavy load. Because particularly I think that Moodle I do not like to use. Students are having many complaints about the Moodles. I do not know the experience of yours. What is your experience about the Moodle? Should we use Moodle for?
No, sir, not at all.
Not good, sir.
And I don't know, Friday's lab, last year Professor Gautam Shah has used something called a backpack. This year I do not know what he is using. I didn't have any.
So MS Teams is quite good.
Huh?
MS Teams is quite good, sir. You can
No, MS Team, but where do you submit those assignments and other things? I think
There is a
G-form is much better.
So you can basically create a assignment section in the MS Teams where you can submit your assignments.
there's particularly a section for submitting all reports and etc.
That I will check. As long as you do not mute myself. Sometimes I find that students are muting the teachers. I mean that the other teachers is complaining.
Sir, you can make everyone attendee.
I think so, but that is a anyway. I'm not very much comfortable about that one. MS Team sometimes that is crashing and giving some different look at different platforms. That is another.